Hi everyone, and welcome
Hi.
to week 4. So today we are focusing on the rock cycle. In particular, we're looking at the engage and the explore phase of our inquiry model when we're in the classroom. So there are many alternative conceptions when it comes to the rock cycle. So it's our job as teachers to provide lots of different examples so that we can simplify it and in a way that students can understand. So the two modelling activities that we're going to do today will demonstrate the sediment and metamorphic processes in a really all-rounded way, so we can see, hear, feel, touch all, like see all of the changes happening as we go. So in year 1, students begin sort of an introductory level by observing changes that happen in the sky and on land. Then we sort of build a bit on that in year 4, and then we look at the changes to the Earth's surface over time as a result of natural processes and human impact. And then we go into a little bit more detail later in year 6. So for this reason, these activities are really beneficial sort of in those introductory phases. So that way we can work to collect a bit of evidence and sort of see it happening in front of us with our Play-Doh today. So then with our nature, like the nature of our spiral curriculum, the rock cycle is explicitly taught in year 8 science. So in the engage phase of the unit, we're going to sort of, talk about what we already know with our prior knowledge and sort of discuss maybe some of our preconceived ideas about how these rocks are formed. So as we know, there are 3 different types of rocks, and today we're focusing on the sedimentary rocks and our metamorphic rocks. So now that we have a starting point, the question to guide our research is, how do natural processes make a rock change over time? So for today's first experiment, we need, so I've got some yellow Play-Doh here. So this is going to be for a little bit later. Then we've got our orange and our blue, so that we can see the 3 different distinguishing colours to make it easier for kids to understand. Then I've got a clear straw, which we've cut into 4 little cylinders to collect some samples. I've got a clear Ziploc bag. Today I'm using this as my little cup, and this is going to be used to squash our samples. And then I have got a water bath here, which has got some hot water in it for a little bit later. So when we're in the classroom and before we can begin our experiment, there are a few safety points that we need to be mindful of. So can anyone think of any potential risks that we may discover and how we can proactively avoid these?
Well, with the Play-Doh, the kids with the Play-Doh, you definitely wouldn't want them ingesting it, or maybe, having the residue on their fingers, getting in their eyes, anything like that. So to avoid that, I guess, in the classroom, you could discuss like 5 or however many rules with the kids and go over that beforehand and really make sure they understand exactly what not to do. And this would also mean monitoring them really closely throughout the experiment, so you know that they are behaving, they're listening, they're doing the right rules and everything like that. So when creating the rules, you could speak to the kids beforehand, ask them like what they think some hazards might be in the experiment to get them involved, get them engaged and feel a part of the whole process. So you could ask questions like, why can we not eat Play-Doh? Is it safe to be placing these objects near your eyes? Is it safe to throw them across the classroom, or things like that? And obviously they're going to be like, no. And then it helps us create some nice rules that they all agree with.
Definitely.
I think, also students like burning themselves while using the hot water and then touching the Ziploc bag in activity 2 could potentially be a definite safety risk. So I think maybe conducting the experiment in small groups and where each member has assigned roles. So, and even having their own health and safety manager to ensure that students and also ensuring that students are aware of the dangers of burns to the skin. So that could be in the set of rules that you were just talking about, Alicia. Yeah. Alternatively, you could have the teacher only handling the boiling water. I guess it depends on the age of the students, so what year level it is. And then the class would just take observations as the teacher conducts the experiment with the boiling water. And yeah, so I think in terms of what the teacher would say, the teacher would ask the students to elect a health and safety manager who then maybe identifies the health and safety risks they need to look out for, as you said before, Alicia. And as you said, like giving students the responsibility. Also ensuring that the students know how to handle the plastic bags with care so that no accidental burns occur, and asking them what repercussions is a burn to the skin, so what might happen and why is it important that we look out for it. Maybe students could hold on to a peg instead of the bag as it'll be hot, so the peg could be attached to the Ziploc bag and they hold on to the peg would be a good idea. And ensuring that maybe you give time for the bag to cool before touching it, and making that very explicit and making sure students know the importance of that.
Yeah, I agree with that.
Yeah, totally. And just to add on to like the burning water, another risk is spilling the hot water or the slippery Play-Doh on the ground as well. So I think what we need to do is keep an eye out for the students running in the classroom, and if a spill occurs or on the wet and slippery Play-Doh is found on the floor, then we need to make sure we're cleaning it up immediately. And a way to mitigate that is like teachers can be responsible for putting the hot water into the bag so the students aren't at risk of spilling it or dropping it and where it can get on the floor. Otherwise, if the temperature is lowered, the students could maybe use a funnel because it wouldn't be as dangerous with the hot water, but still is a risk with slipping. And I think in a safety talk prior to the experiment, we need to ask the students to notify us of any spills or slippery Play-Doh immediately, and always point out that we should always be walking in the classroom, never running. And if a student is running, we have to tell them to stop straight away and just make sure they understand the risks about this.
Yeah, I totally agree. I think also the allergies to Play-Doh could possibly be a thing as well. It's really important that we're wearing gloves at all times when handling the Play-Doh, even possibly glasses as well, depending. It really depends on what Play-Doh, did you make it yourself or did you buy it? We don't really know what's in it. So always the safety. And then I suppose when talking to the class, just letting them know Play-Dohs, can have ingredients that affect a small amount of people, allergies, and, what can happen if someone has an allergic reaction. That could probably be good for lots of things as well. In the classroom, there's allergies everywhere pretty much. So ensure students understand, to go to the teacher immediately for help, and that they must always wear, your safety equipment to reduce those risks as well. I think that's really vital.
Definitely. I think we've covered most of those safety points there. So in alignment with our curriculum, so we weren't going to draw upon our inquiry skills, so our questioning and predicting. So we're going to make our prediction based on, our prior knowledge, what we know so far. So our initial hypothesis for our first activity is if we apply pressure to the 3 types of Play-Doh, then they will combine together because of the pressure placed upon them. So what do you guys think about our initial hypothesis? Did you have anything to add?
I agree. I think it makes sense that under heat and pressure, it would change, and the materials, there'd be changes to the materials.
Yeah, I agree as well. It definitely makes a lot of sense. And I'm thinking maybe it'll melt, or I'm not sure, so we'll see.
Definitely agree.
This one I'm excited to see what happens with this one. I'm not 100% sure.
Awesome. All right, so let's get started. So as you can see here, I have set some of this up already. So we have in our little orange ones here. So this is rolled up Play-Doh. So this is going to represent our pebbles. So as we know from our studies, that a pebble is a small stone made smooth by the rounded action of, water or sand. So it's obviously created that smooth, soft feel on the outside as opposed to rough edges. So that's our little pebbles there. Then over here in the yellow, so we've got the effects of wind on the Earth's surface. So this process is called weathering, as the rock or Play-Doh parts get broken off. They get beaten and battered around and sort of slowly wearing down. They're not as smooth though, and this can sort of be shown like if I sort of put them together. And then finally down here, we have the blue Play-Doh, which represents the effects of water on the soil at the bottom of the rivers, which is often moves the layers around at the bottom of the water. So this process we call erosion, as the sediments in the soil get sort of transported around, they get stirred up, and then they settle back down, obviously once the water is quite calm, and then they slowly keep gradually building on each other and as they go. All right, so I'm just going to hand over to Darcy and Beck. So they're going to show us the data observation tables that they've drawn up. So while I'm doing the experiment, anyone in the team feel free to voice any observations that you come across, and they'll record it for us.
Wonderful.
Totally. Okay, so I'll just share my screen.
Yeah, gorgeous.
With you guys. Can you guys see that?
Yeah.
Yeah.
Cool. So this is just basically an overview of our observation table. We've just got the phase and step of the experiment on the left-hand side here. And we're also got, it's going to be like a picture of our experiment here, so you can visually see what the experiment looks like. And then this column here is our observations. And I set it out so that it was activity 1 and then activity 2 as well. Just so that it's very clear about what activity we're actually doing, and yeah.
Okay, cool.
So we'll be filling this out. I'll be doing observations. Darcy will be doing the photos, and we will be filling this out as we go.
Yeah, so we'll just voice our observations.
Yeah, just voice any observations you have, and we can get that sorted.
Cool.
Thanks, guys.
All right, so we are going to get started with the first one. So this is my little cup that we've got here. So I've got my Ziploc bag that I'm going to pop in. I'll just put that up a little bit so you can see it. All right, so I'm going to pop that one in there. So now I'm going to place some of the different rocks, erosion and mud that we have here into our cup. I'm going to put them in any sort of randomly order because, you know, obviously natural processes, it doesn't go in a set way. So while we're doing that, does anyone know what we might sort of find when I pop everything in and we sort of press it down? Does anyone sort of have any thoughts on what might happen?
I think they'll like compact together.
Yeah.
Yeah.
I think they'll change shape most likely as well.
Yeah, maybe flatten out, something like that. Do you also want to take a photo once you've got them in there and then send it across so that we can do our first observation?
Pop some more mud in there. So the aim of this one, so this process is going to sort of show the kids like the movement and the deposition of the rock materials in a sort of a natural environment. So I've got a little bit of everything in there, pop some more pebbles.
So you're just keeping the pebbles as they are, just in like their little balls?
So they're just in their little
well, that could be an interesting thing to see what happens. You know, if you've left the pebbles as circles and then you've got your water, the blue flat, you know, will that then compress maybe into that one more or less? It'll be interesting to see.
Yeah.
So I'll just take a photo of what they look like, as you can see sort of here. That's with all the different ones. I'm going to put them in here. All right, so then I am going to grab my little pestle, which is going to sort of squash everything. So this tool is going to show us like with like applying the pressure. We're not going to squash them flat though, because when we take a core sample, we do need, we can't have it flat because we need to sort of see a cylinder kind of shape. So I'm going to go ahead and squash some of those together. Right.
What are you noticing thus far?
Well, I can see all of the colors coming through, which means obviously they're kind of molding together.
Okay.
It obviously has changed in its shape. So it looks from the top like everything sort of squashed down, obviously not too much. And it's sort of taken the shape of my cup.
Oh yeah.
Oh,
See, you
great.
can see all the different.
I bet
You can see that the blue's a lot bigger.
Yeah, so the clay looks a lot like it's taking up quite a large
Yeah.
amount of the Play-Doh.
You
And
can
the
see
sort of staying in their shape as well.
Yeah.
Yeah, yeah,
Yeah, like you can still see the circular pebble shape.
Yeah.
yeah. So I'll
I've
take
just
a photo of this for our observations. All right, so now I am going to get a core sample. So I've got my little straw here, my cylinder shape. So I want to go through the middle. So I'm going to put it in like this. Try and get a core one. Oh. All right, so I've got a little bit of a core sample that you can see here.
Oh,
Got
that's
lots
cool.
of different colors. So obviously it's really important to have the different colors so the kids can see. If we obviously all had one color, you wouldn't be able to see those layers.
Yeah.
Do you want to take a photo of that? And just having a look at it, I can see some observations that I've noticed. That the red, I don't know, it seems to be larger, if that makes sense, in the layers. So red larger.
The red, do you think the red, I thought the blue, like the mud was quite taking up a lot.
Yeah, so it's there's a lot more blue. There is a little bit of orange. But yeah, mainly sort of those blue, the mud, which is quite, seems to be quite thick and quite dense.
Yeah.
Right.
But you can see all those layers in there, which is interesting.
Yeah. You can see a little bit of yellow as well in there.
Yeah.
And I'll just take my other core sample. We've got two. Obviously, you know, when it comes to our fair testing and things like that, we always want to, you know, make sure we've got a lot of data. You know, we can't rely just solely on one piece of sample. So that's another one there for you to see. Because you can see there is a lot more blue, quite thick.
Well, it's basically because you're taking it from two different parts of it, really. So all rocks aren't going to have the exact same layers in all areas.
That's a great observation. So each sample will have its unique layers.
Yeah. Awesome. All right. So we're going to jump over and have a little bit of a look at some of the observations that we found and compare them.
Cool. So I'll just share my screen. Where is it? Here.
So yeah, we were getting photos as this experiment went on and writing some observations.
That was good. That was really good.
Yeah, cool. That was great.
Yeah. Just a good way of showing it, I guess.
Yeah, it's really clear. I like it.
Definitely. And it's actually faster than your diagrams as well. I mean, you can definitely do either. But it might be a good, thing to use with your iPads and things like that. But and you can get really accurate diagrams too. And
and it's good to be able to see, because then the kids can come back to it and see at each stage, because obviously we're going to keep progressing with the Play-Doh, so it's good to be able to come back and refer to it as well.
And I think the photos help a lot, because sometimes you write an observation and you're like, what? I can't really envision what that actually means. So
have a really real life representation of what we saw.
Yeah,
exactly. And I think in future, once we really finalize this after the experiment is complete, we can go back in and label the diagrams as well to make sure that you are very clear on what each part of the picture actually is.
So key for the colors, like yellow is this, blue is this.
Great. Yeah, it's a great idea for sure.
Exactly. And that's also very aligned with what you have to do with your science inquiry skills anyway. So I think we should go through what our observations are. Is that what we're thinking about looking at now?
Definitely. I think, please excuse any spelling mistakes. That was obviously done on the fly. But I think for the first one, we obviously noticed, and we mentioned it, that a red plasticine or Play-Doh was the pebbles. I think we even mentioned that they were round and small. We had the blue clay, and that felt that was flat and large, and it's sort of a 1 unit material. And then the yellow was in small portions, similar to the red pebbles, but flattened out as well.
Yeah. And then when we did we took a photo of the rocks in the Ziploc bag prior to pressing together, and you can just basically see they're just in there sitting next to each other. They haven't been compacted, or they're not even barely like.
Yeah, nothing
molded.
happened when you just put them next to each other. You know what I mean? Like they didn't automatically just melt or something. They're realistically just in exactly the same format as they were before, just now in a bag, basically.
Yeah, exactly. And then after we press them together, also I'll just scroll back up. You can see that the colors are starting to mold together. There's a change in shape. They do have like a semi-squashed appearance, but the pebbles that are actually in there, they seem to stay in the same circular shape. They're just squashed.
Yeah, they seem to really stand out too, and just stay in that round sort of space as it was squashed. When we did the core samples, which are really cool, you could easily see the layers of your mud and your pebbles. The blue, red, yellow, blue sort of pattern. It just really stayed in a layer formation. It didn't, morph into a green or something like that. It all just really stayed within its different samples. And so we could see that, each sample will have unique layers made up of the different components. In that one
Definitely.
Yeah.
Yeah. And then the last one, it just had more yellow in the sample, but it's still been dominated by the blue because there was a lot of the soil, the blue soil. But yeah, so that was our observations for the first experiment. So we'll move on to the next one. I'll just stop sharing my screen.
Yeah.
And we'll be doing the same sort of thing for the next part of the experiment as well. We'll just be doing the observations and the pictures.
Yeah. All right, so we're going to, I'm going to hand over to Jenna, and she's going to run us through our initial hypothesis for our metamorphic rock experiment.
Yeah, so in activity 2, so we are placing pressure and hot water this time. So we discussed our initial hypothesis as being if we apply pressure and hot water to the combined Play-Doh from activity 1, then they will fuse together because of the heat placed upon them. So yeah, that's what we discussed. Do we all agree with that?
Yeah, I definitely do. It'll be different from the last one due to the heat component.
Yes, yeah. So we are still using that same combined Play-Doh from activity 1.
Yeah.
All right, so as you can see here, I've just got the sample. So I'm just going to make sure that the bag is sealed so that no water actually goes inside of it. And I've got my little water bath here. All right, so I'm just going to take our sample out of the cup, and I'm just going to seal the Ziploc bag so that no water can get inside of it, because obviously that's going to change the experiment and it won't be a fair test. So I'm going to make sure that try and make sure there's no air in it so that we're getting just the Ziploc. Now I'm going to hold onto it with the peg here, because obviously we don't want to be touching the water or the bag directly, because that could be one of our safety risks that we identified before. So I'm going to set a timer for 10 minutes so that way we can sort of see how it changes over time. Same thing again, if you have any observations, just let them know, so then Darcy and Beck can jot them down for us.
Okay.
So now that we've got this one, let's go. So I'm going to start the timer, and I'm just going to pop it in there so that it's fully submerged. It's a bit hard for you to see, but
just
there.
read out any observations.
Yeah, so by the looks of it, it's gone a little bit darker, the colours. So obviously, as we can see, nothing's really changed in terms of shape. They're still the same shape at the moment.
You probably imagine that they won't really start changing formation until a little bit longer, because it's like only just started to heat up.
Yeah.
That's very true.
Just make sure that that's fully immersed in the water so that we can see.
Excellent.
Mark, but at the moment, the colours are going darker. So obviously the water's doing something to those materials.
Yeah. So I guess that's to do with maybe changing its properties or.
Yeah.
Are they merging together at all, or like the colours even, or it's just sort of going darker?
nothing's moving at the moment. Everything's still quite the way that it was. Like there's no colours merging to show that they're moving. But yeah, and as you can, if you can sort of see here, try and move this forward a little bit. It's fully immersed so that way, you know, it's getting all of it. So I'm going to pull this one out. So we've just gone on the 2-minute mark. So I'm going to just pull it out and yeah, have a little look. I'm just going to wait for it to cool a little bit because obviously we don't want to touch it while it's still got the boiling water.
Do you mind taking a picture of that one for us?
Yeah.
Yes.
Thank you.
It might
It
be.
already looks like it's quite heavy.
Yeah, heavy. And are the colours sort of bleeding into each other? Oh, no. Was that purple? Or it's hard to tell. Wait for the picture.
Yeah, maybe if for this one, it might be easiest to like take the pictures and then discuss them, like have a look at them
Great idea.
and discuss the photo. It's a bit hard to see.
All right. So so it's not hot to touch anymore, but as you can sort of see here, without dripping water everywhere, it's gone quite firm.
Oh, yeah.
So when it's squishy and a bit soft, and now it's kind of gone a bit hard again. So I think obviously I've taken it out. It's cooling a little bit and it's going firm. When I first pulled it out, it was a bit squishy and you could sort of move it around. And now it's
quite pebbles
quite
as well.
hard.
It looks like the pebbles have like lost their round shape.
Yeah.
Like I saw before, like they were still quite round, but now they seem to be a bit more fused or like mold is stretched out, flattened.
Red pebbles,
It's a lot more like mush
shape.
Yeah, it is. It's starting to sort of change its shape. So I'll pop that back in there and keep the timer going. So we're about 6-minute mark. So
Beck, are we supposed to be pressing these after every 2 minutes, or?
So we've already pressed it, and now we're just putting it in the water. So this is the heat part of the experiment.
Okay.
Yeah. Yep. So I can see some of the colours are starting to sort of combine together a bit. It's a bit more sort of blended in the bag.
Yeah.
Colours blending. Okay.
And they look, they're quite squishy when they're in the water. Like you can move them around a lot more.
Okay. More malleable.
Yeah.
So it becomes soft again when it's in there, but then it gets.
Yeah. So it sort of changes as it goes. Keep wiggling it around, make sure that it gets all of the water. So the water at the moment is about 70 degrees.
Okay.
It goes down really quickly, doesn't it?
Yeah. Because we started at 90, didn't we?
Yeah.
Yeah, it's gone down a little bit. All right, so I'm going to have another look. We're at 5 minutes now, so I can actually see on the bag here, it's actually some of the Play-Doh is rubbed off onto the bag. So obviously the water is starting to have a bit of an effect on it and sort of breaking it down, I guess. You could sort of say like it's starting to fall apart a little bit.
Yeah.
Okay, crumble, would you say?
Yeah.
Sticking to bag.
So like maybe would that be the heat rather than the water? Like I feel like the heat might be changing or like making the Play-Doh go onto the bag.
So if I squish it around now, oh my goodness. So if I squish it around, you can see, there's some like, it's starting to become a bit more sort of liquidy in terms of like.
Can you take a photo of that?
Yeah. So it's softer even. So
it's a lot more like I can squish it now. It's quite easy to move, and we've got the colours are sort of a bit blended. Like we've got a bit of a green colour happening now.
Yeah.
Okay.
As opposed to those clear colours, and we've got a little bit of colour.
It's running.
Yeah.
Oh, the colour's running. Cool.
Right. Interesting.
All right.
So
Yes, it's
colours have
definitely
to go to green.
the colours are moulding. All right, I'll pop it back in. So we've got just about 3.5 minutes left. Oh, I was going to take a photo, wasn't I? Sorry.
Yes, please. That'd be great.
Right. You can almost like imagine what that would be like in the real world when these rocks are melting. Is it like a residue of the rock that's kind of coming off, or is it the color and the water? Like, that's something to think about. Like, what is that running water in there?
Yeah.
Is
Yeah,
that
because obviously we're doing it with
water in the Play-Doh.
material. Yeah. All right, how much time we've got? 3 minutes left.
Okay.
So I can definitely see those colours have are moving around the bag as I sort of move it and submerge it in the water.
nice?
So obviously, like the hotter the water would be, it would have more of an effect. So
More of an
obviously, if the
effect.
water was
Yeah.
quite, sort of around 50 degrees and under, it's probably going to take a lot longer in the classroom, which you've got to think about as well, how long that's going to take. Obviously, our water is quite hot because I've just boiled it, but that would be a safety thing as well.
For sure.
All right, we've got 2 minutes remaining. I can really see it's quite like heavy.
Yeah.
Like the weight in the bag now.
You can see
Look at the green sort of colours.
Interesting.
Yeah. It's really melted, hasn't it? Like, it's really.
Yeah.
And they've all pretty much compacted together. Like they're not sort of spread out. Like everything's kind of all in the one area, condensed.
This might be a weird question, but is it like, you know how when things fuse together, you can see like the line where it's fused? Is it all just like one now? Does it seem like really, fused together?
There is still a little bit of like in some parts they're all kind of sort of mashed together, but you can still see a bit of a line, obviously, where the different colours have come together. Yeah.
Yeah. Okay.
All right, we've got just 1 minute to go, and then we'll pull it out for a final check and see how
Excellent. So you'll be doing the core samples again for this one?
Yep, so we're going to do 2 core samples again.
Interesting
and
see the differences for sure.
Yeah.
Yeah.
Any changes?
I can imagine it'll be quite similar to the ones we did in activity 1, where it's like 2 very different samples, because they'll both be quite unique.
Yeah.
Definitely. And maybe some different colours in there or something.
Yeah, I think with the activity 1, we could still see, each layer, whereas this is a bit more blended.
Like a clear divide.
Which obviously, once we sort of go into our CDSU, will be explained a bit more as to sort of why that's happening.
I think the green colour is really interesting too.
Yeah, I think that's definitely big.
Yeah, that's very interesting.
Yeah, I feel like we'll see some of the mixed colours in there when we get our sample.
Yeah, I think that's a big difference between the first test and the second, is that random green colour coming out of the works. So good to see what the sample looks like. Sure.
Yeah.
All right, we're just about done. Close our 10-minute timer, so I'll just let that cool for a second. As you can see, yeah, pretty much all of those colours have sort of moulded together.
Mm-hmm.
So there's quite a lot of sort of liquid kind of residue.
And I feel like, like what you were talking about before, Darcy and Beck L, when you're saying like the distinct lines, like I feel like they are quite blurry, like rather than being very distinct lines, they're like quite blurry.
Yeah.
When the colours meet.
Yeah. So you can really sort of feel, you can move them around. They're a lot more like malleable. Like I can really get it in my hands and change it to the shape. If I squish it, whichever way I squish it, kind of it just sort of molds. And obviously it's still.
Are you noticing any like even more color changes when you're doing that?
Yeah. So as you can sort of see here, pretty much they've all sort of molded together now.
Oh yeah, and they're quite fuzzy. You got the lines between them, definitely.
Yeah.
Can you take a photo of that one when you can? That'd be great.
Yeah, definitely. Yeah. So it's really sort of changing to the sort of shape that I'm pressing it into. So I'll take a picture of that and then we will do our core samples.
Awesome.
All right, so I'm just going to move this hot water out of the way. All right, so I'll grab my, we're going to do the 2 samples. So I'll grab that one. So our core sample, obviously taking into account that it's, you know, will be quite hot.
Yeah.
Because the first sample was still quite a solid form, you know what I mean? Like this one might be a bit like...
Yeah, this one's definitely a lot
running out.
easier to sample. Oh.
Okay.
All right, so sort of as you can see, wipe the excess off. As you can sort of see there, it's all blurred in. We've got like a little bit more of a lighter orange now because obviously the colours have combined.
Yeah.
Sort of in the corner up there. But it's a lot more blended as opposed to the other one.
Yeah.
And then I'm just going to take another sample from a different spot so that we get some, you know, different results.
Right.
All right, so I'll do this one. Try and get nice, solid sample so that we can see. Oh, wow, I've got lots of different colors in this one. This is a really good sample, actually. There's lots of different layers.
Wow. And you can see, I think, like the main difference, what I see is that in the first experiment, it was very like orange, blue, yellow.
Yeah.
But this
Yeah,
one is like, you know, green, blue, orange, yellow, green, blue.
Yeah.
It's like, it's
Sort of
not in
morph
like
into each
very,
other.
Different.
yeah, not very
Definitely.
distinct layers of like the 3. It's more like spread out.
Very
Yeah,
blended.
definitely.
Yeah, so you can see all the different layers. You know, obviously once, you know, with our erosion and in the water, obviously that's, you know, as it settles and then it builds and then it moves and it changes. So we can see all of those layers. They're not perfectly placed. They're quite
They've been moved around.
quite
Very interesting.
Cool.
Cool.
Very good.
so I'll take some photos and send them through so we can pop them in our experiment. So I'm going to hand over to Darcy and Beck again, and they're going to run us through the tables that we've developed.
All right, thanks for that. Let's have a quick look at what we just observed. So pulling up our data table here. Can everyone see that?
Yep.
Yes.
Yep.
Excellent. So this is activity 2. We started off with the explore phase here. The metamorphic rocks just as they were. So observing that the separate samples were still pretty obvious here. Clear division in the red, blue and yellow samples. Now, then we put it in the water. Darcy, do you want to go for it with that one?
Yeah, so once we put it in the water, we could see that there was like darker colors. At first it was squishy and soft, but then it hardened quite quickly. So as it cooled down, when it got out of the water, it started to firm up. And the red pebbles were less obvious in shape and they kind of merged into each other. And then afterwards, we took it out after another 2 minutes and the colours are really blending, really soft in the water and then once again hard out of the water as well. They're kind of starting to fall apart almost, sticking to the bag a bit, and it's quite soft and squishy apparently to touch.
And then when between, I think, 2 and 5 minutes, that's when we really noticed that the colours were blending and it was really soft in the water, but then hard out of the water. And the colours here really started to run. So you noticed that liquid in the bag as well, I think, was a big changer. So liquid in the bag and then this new sort of green colour started spreading through the bottom of the bag in that liquid. And then that was sort of the same at the repeat too. So they were very condensed. You could see that packed sort of condensed nature of the Play-Doh, and the green color here really obvious, blending together, clumped together, blurred lines between the colors as well. So I think we could see that they're a bit more obvious up here, whereas these were starting to blur into each other. So malleable and squishy, and a blurry distinction
Yeah, and they were really quite fused, weren't they? So in our final observation at 8 minutes, we could see that it was really green at the bottom of the bag. There was a lot more liquid inside the bag as well. We're not really sure what that's from. It was sticky. The red pebbles are still clear, but the blue and yellow have really merged together more than the red. And I guess that's kind of just like what we could think about, like the color wheel as well. That's why it's probably going into green, because yellow and blue, they come together. And then we did our core samples, and so our first core sample, we noticed it was a lot easier to get it. It was blurred between colors. It had multiple colors in there, and the green was really quite blended.
Yeah, that was the same with the second one too. The other one, it was quite pretty actually. So morphed into each other, and just not that as much distinct layers as the first experiment. So there was lots of layers still, but they were more, they just morphed into each other more. So that's pretty much what we got from our data table. So I'll stop sharing there.
Cool.
Need the polls there.
Can someone pause so we could stop sharing? Can I make you stop sharing?
I got it. I figured it out. Stop sharing. Sorry.
Okay, so I thought it was a good idea to show you guys a little graph that we prepared from the observation table, just another way of showing it. So I'll just quickly share my screen with you guys.
Because once you have the data and you've got the photos and things like that, it's really limitless as to what you can then do with it and display it for the class, for yourself, for your records and things like that. So
exactly.
This is great.
Yeah, I really like this one.
It looks really
So
nice.
this one's, thank you. So this one's like the rock cycle. So you can see here, we've got the sediment, got a picture on what it looked like at the start. And then we can see the compacting and cementing. Just through here, make that a bit bigger. So we pop one of those photos in there. Then we've got one of our core samples here as well. If you come down to the heat and pressure, there we've got our metamorphic rocks beginning to merge. And now here it is in the core sample. And then although we haven't touched on this in the experiment, I thought it was good to go through that. Yes, it can become a sedimentary rock again, or a sediment, through weather and erosion as well.
So it's really, it's good in the circle.
Yeah, and it's like good for the kids to be able to see it like this as well, to see it as what it is. It really is a rock cycle, because all the rocks can really form into each other. And then I also thought it could be a good idea to do this timeline as well, although it's not the same as like a cycle. It still has like the phases. You can see, this is what happened at first, then it goes to this, and it's basically very similar. So in future, after we've finished this experiment, I'm going to pop in all of the labels, maybe a few observations, just so this can be a complete graph. But I just think it's a really good way to be able to visualize it for the kids, and just in science in general. I mean, anyone would benefit from seeing it like this. Really,
it would be great in the classroom too, like even on the wall as well, using even the photos that we've taken ourselves, so relating it back to ourselves, and then having that on the wall, showing the cycles. So it really, you've got so much uses for your photos and your data and your observations there.
And I think having the observations like next to each of the stages, or like the photos, is a really good idea as well. I think that'll just cement their understanding.
Definitely.
Especially with having those photos there, that's really handy as well, as opposed to like something like this is probably a bit harder to put into like a bar graph, or because it's more about observing.
It's impossible, really. It's more of an observational sort of experiment. So and when you don't have that sort of tangible, I suppose, qualitative, quantitative, all of that sort of stuff, it's just easier sometimes to be able to show different ways of displaying it.
I agree. Really good.
Okay.
I'll stop sharing that now.
But look, we're recording data in the classroom, sort of as we have been discussing. It's a really important skill for students to learn, because it really does promote the development of a range of oral, visual, written, and digital literacy skills as well. So it really helps students' inquiry skills of representing data in meaningful ways and useful ways, as we can see that you can take that from a simple observation table, pop it into a secular sort of table, and it displays it in a more meaningful or useful way. And also helps them identify your trends, your patterns, your relationships in the data, and use that evidence to, justify your conclusions as well.
Yeah, and these skills are also really effective, and they enable efficient organization and documentation of information. So such as sketches, diagrams like we've just had, note taking and labeling during science experiments as well.
Oh, for sure. And, the experiment will see students using different recording devices. And so a camera to record your observations and data. And as an educator, it's also really important just to note that we have to provide that proper instruction on how to effectively, use the devices as well to make the process smooth and easy for us during this experiment. Because, us doing this ourselves, we've had to, take photos, put it into the thing. So with your students, it's really important that we give them the best opportunity to learn how to use the technology as well. So we need to teach them, your photos that you take, they need to be clear, they need to be precise. You can't have blurry photos, you can't have, out of frame and things like that. So the recording of the data must be in line with the photo and accurate to what we're observing as well.
Definitely.
And the students are welcome to draw labels, of course, to assist and accurately show what the materials are as well.
Yeah, and the students will definitely benefit from using a variety of these organizational tools for managing and compiling their data. So examples such as like journal entries, observation tables like we've just done, and then our labeled diagrams which are to come.
Yeah, for sure. And again, you just need to make sure the students are really confident in this form of data recording. And that will be through many practice runs as well before the experiment takes place. So this is, quite a detailed experiment that we've done today. And you'll have smaller ones running up to it as well to give them opportunities to learn this data recording skills. So opportunities also for cross-curricular learning here as well in your maths, ICTs with your data and tables. So running even units in sync could be highly beneficial in constructing knowledge on record keeping and data. So having, your maths data and things like that running at the same time, it's just, easy to translate those skills across.
Yeah, definitely. And as teachers, we're going to have to encourage the students to be really precise and accurate when they're recording observations in their tables. So we need to remind the students at all times what the difference between observation and an inference is. And we want to see descriptions on the senses, like what does it look like, smell like, feel like, which is basically what we've all written in our observations. We also want to note changes and effects in the senses as we observe and document the experiment too.
Yeah, and that'll really help in the experiment later on when we rely on these tables to form our final hypothesis and discuss the CDSU as well.
Yeah, and this kind of data recording is very different to just measuring and creating graphs. So as we've been discussing, it's not just your usual typical measurement of water levels or whatnot. It encourages students to understand visual representations and create their own. It also allows them to foster new emerging ideas, relating back to existing knowledge, and then build on it as well whilst learning these new skills.
Yeah, and like supporting the students when creating these tables again is just super helpful to work in smaller groups, I think, with this one as well, or even at least in pairs, just so they're able to band together to correctly label and record meaningful observation, but also help with the delegation of your tasks and shared responsibility with, the water, the pestle, the core samples and everything like that. So, group members can share in the process of this experiment as others take the photos, and that'll just help with the time and nature of the classroom activity as well.
Totally. So what did you guys think in regards to the effectiveness of these tables? What was your guys' thoughts?
Well, after looking at them both, I think especially the last one, the cycle, it relates to content knowledge, and it's really clear, has a really clear visual representation of the whole process. The data tables, however, though, are effective with note taking because you can just jot down things so easily, like all your thoughts and everything, and you have the pictures as well. And it's a great way for teachers to conduct formative assessment because, you can just see that truly what they understand and what they think because it's all just jotted there. You can just see it really clearly.
Totally.
Yeah, I agree. So it's time now to formulate a final hypothesis. Do you guys think it's beneficial maybe with this experiment to have multiple hypotheses for this one since we have 2 activities? I don't know, what do you guys think?
Yeah, well, probably by splitting them, the hypotheses up, it allows us to be more specific, because then we can sort of first, from our first-hand observations, then combine it with our inferences, because obviously it's different on each experiment. So we're kind of like, have to generalize otherwise. So we're finding out more specifically the reasons why they were impacted the way that they were.
I think we should maybe have one for each experiment and then maybe like an overall final hypothesis.
Oh, good idea.
Yeah. Okay, cool. So with our final hypothesis, we have to include our observations and our inferences. So what key observations and inferences do we think we should include in these hypotheses?
Definitely the layers were a big one for the for both, but I think the layers and the different way that layers will definitely be a thing in there, an observation anyway.
And you can see they kind of molded and merged a bit as well. There was the mixing of the colours.
Yeah, that fusion or melting. So
so maybe for activity 1, we can formulate when different sediments are layered and compacted, they harden to become rocks because of the pressure applied to them.
Yeah, that's good.
Yeah, I like that a lot.
And maybe for activity 2, when heat is then added to these combined sediments, they melt, fuse together, and then harden due to the heat applied.
Yeah, to the heat applied.
I like that.
And then, so for an overall, we could maybe conclude that when put under pressure or applying heat to the sediments or sedimentary rock, there's obvious changes to the rock's formation due to the natural processes and the conditions, like environmental conditions.
Yeah, love that.
Yeah,
that's good.
Okay, great. So then that takes us to our CDSU understanding. So a rock is made up of 2 or more minerals joined together that have been heated and then cooled. These minerals naturally occur as crystals. And a crystal is a regular internal structure which leads to the geometrically regular external structure seen in rocks. And that's through the repeated arrangement of atoms, ions, and molecules. So we have 3 broad categories of rocks, and they're identified by the way they're formed. So we have igneous, metamorphic, and sedimentary. All rocks can transform from one rock type into another, and the rock cycle explains how and where these processes take place. The process of changing from one rock type to another can occur over thousands or even millions of years, and it is a cyclical process with no beginning, middle, or end, which is very important to make sure our students understand. So in this experiment that we conducted today, we just focused on sedimentary and metamorphic rocks. Sedimentary rocks are formed by weathering, such as wind, water, and ice, eroding existing rocks on the Earth's surface and carrying away these rock particles along with animal and plant particles. And these are carried to the bottoms of lakes and oceans. These particles, or sediments, are then buried by more sediments where they compact and harden. And fossils are actually found in sedimentary rocks, and they can't be found in metamorphic or igneous rocks, which is pretty interesting. So then metamorphic rocks, meta means change and morphic means shape. So these are formed when rocks become buried deep in the earth or near molten rock, and they're changed by heat or high pressure over time. This heat and high pressure changes their properties, causing them to become harder. Slate is a common metamorphic rock that forms from the sedimentary rock shale, or similarly, the sedimentary rock limestone will change into the metamorphic rock marble under the right conditions. So although metamorphic rocks form deep below the Earth's surface, they can be exposed due to erosion and subsequently be exposed to weathering. This weathering can then turn the rock into particles which may be used to form sedimentary rocks, and thus the rock cycle continues. The other type of rock that we didn't touch on in this experiment is igneous rocks. When rocks become buried at even greater depths, the extremely high temperatures melt the rock and form a liquid called magma. This magma then rises up and then it hardens to form igneous rocks. these rocks can be formed on the Earth's surface or actually in the Earth's crusts. So I'm just going to share my screen as I have just some examples to show you. Here we go. Can everybody see that?
Yep.
Okay, cool. So here on the left side, we have sedimentary, and I find this really interesting because you can actually see all the different types of rocks that are still in there, or the sediments. Yeah. So like you can even see like this cool shell down here, which I think is pretty cool. So yeah, you can still see all the sediments that are compacted together, which is pretty cool. Then metamorphic rock, we can't see that as much. So we can see that it has been fused together. And I guess this is what we saw in our experiment as well. There is still the different sediments in there, and you can see that. You can see those color changes and things like that. But it is definitely more fused together, which we saw, they're back. Yeah, which is pretty interesting. And then igneous rocks, looking very different again. You can see it's a much darker color. And so these have actually, they've become fully liquid, they've become magma, and then they cool and become rocks again. And so you can see they don't have the same kind of appearance as sedimentary and even metamorphic, where you can see all the different sediments in them. They just look like one whole, same color, same kind of surface and things like that, which is pretty interesting. Cool.
That is
Super cool.
Yeah. It's cool to see them side by side as well and see the differences. All right. So an interesting thing to consider is the connection that this experiment has to actually last week's experiment. So last week we were talking about soil. So soil is made up of rocks and rock sediments along with other materials that we learnt last week. If we look at this from a post-humanistic perspective, soil is essential to grow plants. Therefore, it's critical energy or food production for animals, including us. So not only is it essential for agriculture, but almost all of the antibiotics created to fight diseases comes from soil microorganisms, which I thought was super interesting. I had no idea about that. And so, yeah, I found that super interesting. So if we think about how essential soil is for all living things on the earth, and then consider how soil is made up of rock sediments, then the relationship and essential nature living things have to rocks is like clearly seen. And I think that that is super interesting. So it's crazy to think that something so important is made up of these rocks. So yeah, super essential to all living things.
Yeah,
Definitely. Yeah.
That's cool.
Sharing that with us, Jenna, and enlightening. I didn't know myself either. I guess it's also something to think about, you know, our impact as well. Not only is just the natural processes, but how we also impact our environment and things like that.
Yeah,
so I'm now going to hand over to Alicia, who's going to talk us through the behind the scenes when we were developing and thinking about our left-hand side.
Perfect. Thank you. Well, good job, everyone. I feel like there's definitely heaps to talk about and heaps to include in our left-hand side. Reflecting on our mind map from last week's experiment, I feel like that was a great way to display everything clearly and to be able to branch out in so much detail. And because this week's experiment had multiple, so 2 different activities, which means, you know, there'd be plenty to say, I feel like a mind map again would work really well. Do you guys agree?
Definitely.
It just will give us so much room to be able to, you know, get everything we want to say out.
Yeah.
And see how they all link back to each other as well.
Yeah.
It's a very
I thought it was a great way to do it.
Yep.
For sure.
Should we go over just some benefits of the mind map then, in particular for today's activity? Well, we know mind maps are great for encouraging positive social interactions amongst students, but can you think of any other positives to the mind map for our left-hand side?
Yeah, so I think the mind map also acts as a reflective tool that students can return to and add to at any time to increase their knowledge and understanding of the science content.
I think the mind map allows students to review and reflect the actual activities as well, and explore the content in more detail, which helps advance their learning.
Yeah, I think that is a really good point. And that will also be a great opportunity for students who maybe didn't understand, a certain concept in the activities to then like revisit and hopefully correct any misunderstanding. Yeah.
Definitely, especially with those alternative conceptions as well. But with the mind map, it sort of links to our Vygotsky's learning theory, as we're sort of focusing on their social interactions in the learning. So the class gets to explore new science topics, and that we can see those links between new and past content using that mind map.
And they really just encourage the class as well to think as a collective group. So to bounce ideas off each other and work with different, ability levels. I think they're just such an effective way of being able to bring everything you've got in your brain from what we've learned to the table, and then discuss it really.
Yeah, all great.
Totally.
I love those. Yeah, I think I'm really happy with our choice of doing another mind map. I just think, it's such a good choice to show everything that you've learned. So now moving away from the why we are choosing it, let's discuss what we were actually going to include in our left-hand side. What do you think?
I think like last week, we should just stick to the science content that we learn, and then pedagogy examples, probably like, what we might do for next time, what the challenges were, what we liked about the experiment, and just anything that we really learned or thought was good or bad about this experiment. And just
like which data table you thought was more appropriate, or like what you took away from it. And how like maybe it links to the CDSU and all of that. Again, mind map's just such an effective way to get it all out there.
Yeah,
I think we also had we did discuss some things that we might change about the experiment, so I think that'll be really good to include in there as well.
Effective for that, to put all of that in there.
Yeah, definitely. Well, that wraps us up for today, guys. So thanks to everyone for being such active participants. And I quite enjoyed sort of getting a bit hands-on, obviously in those early engaging stages of learning the content and learning about the rock cycle in a really fun way.
Yeah, me too.
Thanks, guys.
Bye.
Thanks, guys. Bye.